How do we find the percent composition of chromium and oxygen in chromium 4 oxide? Turns out it's a very simple process. First, we've got to find the mass of this compound, and then we can easily find the percentages. Watch. Bam! So the first thing I'm going to do is write down the elements I see in the compound. So I see chromium, Cr, and I see oxygen. Next is then, that looks like a 6, or it looks like a 5-year-old 6. That's better. Next, we're going to write down the number of atoms, right, of each. So that's where the subscripts come into play. So at the bottom of chromium, there is an invisible 1 down there. So that means that there's 1 chromium atom. And then there are 2 oxygen atoms. Then we're going to take those number of atoms and multiply it by the mass of the element. Where do we find that? To the periodic table we go. These represent the masses. Chromium's mass is 52. Oxygen is 16. They can either be in grams per mole if you're doing molar mass, or AMU if you're doing molecular mass. Can't speak that fast. So let's write those down, right? So the mass of chromium is 52, and the oxygen is going to be 16. Each oxygen weighs 16, right? Each mole or each atom. The magnitudes are the same, but the units differ. Now to find then the total mass of that particular element, we simply multiply the atoms by the mass, right? So 1 times 52 is hopefully 52. 2 times 16 is going to be 32. And then when we add this together, we simply get a total of then 84, and that is the total mass now of that compound. So this was that first step, right, to find the total mass. So now to find the percent, it's simple. I'm going to add a column to the table. Bam. So to find the mass percent of, let's say, chromium, we need to take the total mass of that chromium, which is 52. And then we're going to divide it by the total mass of the entire compound, which is 84. This is a simple percent calculation and multiply it by 100, meaning it's part over whole times 100. All right. So when we do that math out, this works out to be approximately 61.90%. All right. And then same process for the oxygen, right? Take the total mass of the oxygen, which is 32, divided by the 84. Forget all the zeros because it doesn't really make a difference. You might say, well, doesn't it matter with sig figs? Yeah, but who cares, right? Who cares? And then we're going to round that answer 38.10. And what should happen is when you add these two together, you get a total of 100. Thanks for tuning in, ladies and gentlemen. That's how you find the percent composition of chromium and oxygen in chromium 4 oxide. I will see you in the next video. Take care.